Hi everybody. So I'm going to do right now what's called a screencast to explain to you how to find radicals. That way you can play this over and over again in case you're having a little bit of trouble. So this is going to be a review of radicals right here. And the first thing I want to go over is what is a radical? What is a radical? So a radical, first of all, it's a symbol. And it's a symbol that looks like this. Just a second, opening it. It's a symbol that looks like this. That's a radical. And it means the square root. So square root means it answers the question, if I take this number and multiply it by itself, what number do I get? So, in other words, if I say the square root of 9, that's the same thing as saying 3. Like that. Square root of 9 equals 3. So 9 is a perfect square. So since 3 squared equals 9, the square root of 9 equals 3. It's basically going backwards, or it's undoing a square. And that's well and good for ones that are perfect squared. I mean, we could say the square root of 25 is 5. Radical 25 is 5, or radical 36 is 6. Here, I'll show you. So we could say radical 25 is equal to 5, because 5 squared is 25. We could say the square root of 100 is equal to 10. The problem comes when what we try to do is simplifying radicals. And I don't know where these rules came from, but there are some rules about simplifying radicals. Rule number 1, let me just scroll down so you can see. Rule number 1, when you simplify radicals, is that radicals you can't have a perfect square inside a radical. So perfect squares need to be factored out of radicals. Secondly, radicals can't be in the denominator. Okay, so let's look at the first one. Here's the first rule. Perfect squares need to be factored. So the square root of 150, radical 150. You could think about what that number is. We know that 12 squared hold on a second. 12 squared is equal to 12 squared is equal to 144. 13 squared is equal to 169. I'll do that a little bit faster. So 13 squared is equal to 169. So we know that 150 is going to be somewhere between 12 squared and 13 squared. It's going to be somewhere, it's going to be somewhere between 12 and 13, because 12 squared is 144 and 13 squared is 169. And if we wanted to use a calculator, we could easily enough open up our calculator and say, okay, what is the square root of 150? We just say 150, and then take the square root of that, and we'd say it's 12.24, and we could just write that down. But for some algebra classes, it's useful to actually simplify or express in simplest form what this square root of 150 is. And to do that, you need to factor out perfect squares. So you look for a perfect square that's a factor of 150. And you should be able to tell by working it out a little bit that 25 is a factor of 50. Sorry, of 150. So we'll start working here. So 150 is equal to the square root of 25 times, that's the symbol for times, 6. 25 is a perfect square, so the square root of 25 is equal to 5. So if it helps you to think about it, you can think of this as the square root of 25 times the square root of 6, like that. And so that becomes equal to 5 times the square root of 6, which is 5 root 6. There. So the square root of 150 is 5 root 6. Now it's simplified. If you take 5 and you multiply it by the square root of 6, you get the same thing. You get 12.24. You can try that out on your own if you're not sure. So if you have one like this, where you've got 3 times the square root of 63, this is the same thing. I'll show you the same way. So 3 times the square root of 16 is equal to 3. When you write the number in front, it's times, so it's 3 times the square root of, and then you look for perfect square, and so 9 is the biggest perfect square you can factor out of it. You always factor out the biggest one that you can. So it's 3 times the square root of 9 times 7, which is 3. So that's the same 3 that we had right here. So it's 3 times, the square root of 9 is 3, so that's 3, and then times the square root of 7, which is 9 times the square root of 7, so it's 9 radical 7, or 9 root 7. Oops, 9 root 7, like that. So 9 root 7 is the final answer. Finally, you can't leave radicals in the denominator. Now, I don't know why, but that's just the rule that they have. And the way we do that is something called rationalizing. And rationalizing is used in day-to-day life, but in math, it means that you make sure there is no radical, no square root in the denominator. And you're going to do that by multiplying the top and the bottom by whatever radical you have in the denominator. So when you rationalize the denominator, you start with what you've got, which is just 2 over root 10, but then you multiply that by root 10 over root 10. And so you're left with, in the numerator, it's okay to have a radical in the numerator. So in the numerator you have 2 root 10. And in the denominator you have root 10 times root 10, radical 10 times radical 10, which is just the square root of 100, which is 10. Because if you take the square root of something times the square root of something, you get that something back. Then you reduce, so you divide the top and the bottom by 2, and you get the square root of 10 over 5. Okay, so remember those things. Factor out the biggest square root you possibly can. So you get 5 root 6 here. That's the same thing as root 150. Radical 150 is 5 radical 6. If you have a number in front, you just multiply that by whatever you get when you factor out the biggest perfect square. So 3 times root 63 is the same thing as 3 times root 7, which is 9 root 7. And if you have a radical in the denominator, then you multiply that radical in the denominator by the top and the bottom, and then you simplify. So you get 2 root 10 over 10, which is just root 10 over 5. Hope this helps.